Should be live. Make sure my mic was unplugged, so got to make sure that I'm on the Shure mic. All right, and I know people arriving in. As you come in, say hello in the chat and maybe where you're watching from, why you're interested in building agents, or are you already building agents? That's always really fun to hear. And give me just a minute here as I get my settings right. We don't need blur. And let me just send one blast to the event calendar saying we're live. And Kevin said hello from San Diego. Welcome. Yeah, I'll say hello in the chat as well. And I'm streaming from Seattle. And as a note, as we're waiting for people to come in, the link to follow along should be in the description as well. And people always ask about a recording, so you can always come back to this same link where we're streaming, and you should have the recording. While we're waiting, I'll share this in the chat as well. We're going to go through some slides, and then hopefully some of you want to follow along or reference the code. It depends on how you want to kind of go about this workshop. Some people like to just watch and ask questions in the chat, and that's great. If you actually want to follow along, I've linked a GitHub repo and a notebook with some instructions on how to get set up. And I will also go through the setup when we get to that point. If you already have UV installed in Git, you should be able to set this up within like a minute or so locally. But if you don't and you want to do a clean environment, I'll actually go through and show you how to do it in GitHub code spaces. It should be really easy as well. And just as a note, there should be, I think there's a Colab link in there. Colab has some sort of update they did last week where it kind of breaks the output from not executing Python on a Python cell, but if you're doing like calling a python.py file and using the cell as a terminal, it now parses the output, at least from Flyte, kind of weird. And so you get like an input box instead of the clickable link. So just as a note, don't use Colab today. I'm either going to see if I can get a fix for that, or they might put in a fix themselves. Again, like there was some update last week that caused that to happen because I had run this previously in Colab when I was testing. And then, of course, the night before going live, it breaks. So just as a note, we'll go through and we'll use code spaces. It's closer to an actual development setup anyway. And you'll be able to kind of see all the files better. So actually might be a better experience. But again, I'll go through that when we get there. And for people just joining, say hello in the chat. Someone else said they're watching from Calgary. Awesome. I'd like to go there sometime. I've never been to Calgary, only Vancouver and Toronto. And again, I'm in Seattle, so not too far from Vancouver. And we'll wait another minute or so before we get going into the content. And again, for people just joining, we're going to go through some slides, set up some of the concepts here, and then go into the code. And I shared the code in the chat. It's also in the description as well. And it's up to you if you want to actually follow along. If you signed up to the Luma event as well, I've given you access to a Flyte cluster temporarily, at least for the workshop. So we'll actually be able to run these agents. Like I'm going to go through some of the concepts, and we'll build these agents in Python, and we're building a planner type agent, and I'll talk about what that is later today, but this graph might give away. Generates a plan, and then executes those steps. If you design it well, it should be in like parallel waves, so it can actually look at dependencies, do some amount of steps, and then if there's dependencies from another step, then it can go after that first wave. And then we're going to be running these inside of the Flyte to platform on Union. But just noting that we're going to go through and implement this kind of from scratch. By that, I mean, we're not going to use an agent framework. And you can run this locally. So you can do it in the Flyte platform. You can also run it locally, and we'll go through both. So you're going to get kind of two things today. Is if you've never built a planner agent, you will be able to do that in Python, run it locally. And then if you want to kind of go the next level and productionize it and get the durability and scalability piece that Flyte brings, and we'll talk about that here shortly, you'll be able to do that as well. So you could do one or both of those, whatever is most interesting to you. Hello. And I saw a big chunk of people join in. So again, say hello in the chat, put where you're watching from. what are you building? I think that's really interesting too. I mean, people are here because they're interested in building agents. That's what everyone's doing right now, right? So I'd love to hear kind of what people are building. And I'll throw this link in the chat again. This is going to be the code that we're going to walk through. You're welcome to start poking at it. You're welcome to start setting it up if you want to run it locally or in the GitHub code spaces. If you're weren't here at the beginning, I probably should have taken this out. There's a Colab link. If you try to run a Colab today, I noticed they did an update sometime last week where it breaks some of the outputs. So you might not be able to authenticate in Colab. You can still open it in Colab and like look at all the code because it's all printed out. So if you just want to do that, that's fine. But you might as well just keep it in the notebook that I linked to on GitHub then. All right, is everyone ready? We're going to go through some slides, and then we'll go through code. Let me put this in presentation mode. And again, say hello in the chats. I keep seeing people join in. So I'm gonna get started, but as people come in, feel free to say hello in the chat. So again, this is building a planner, building planner agents with parallel execution. So we'll see what that looks like here in a minute when we get to the code. Quick intro. My name is Elliott. I'm an AI engineer at Union. We also have our open source called Flyte, and I'll talk about that shortly here. It's a widely used orchestration platform. If you want to connect with me on LinkedIn, you can. And then introduce yourselves. So again, I've already been doing the call to action, but I keep seeing more people join in. Say hello in the chat. Where are you watching from at the bare minimum? I think that's kind of fun to see where everyone's joining in from. And then if you want to put a little bit more about what you're building or what you're interested in, that's always really cool too, to see kind of what people are interested in doing in the industry. And if you want a little bit more of a permanent introduction area, we have a Slack channel for Flyte. A lot more goes in there besides just Flyte talk. Like we talk about other events and stuff that we do. I run an AI book club that we read a new book every month. That's all kind of listed in there as well. Someone said they're coming to us from San Francisco. I love San Francisco. I go down there a decent amount. I'll be down there in March for GTC, which is in San Jose, the NVIDIA GTC, but then I'll be in San Francisco for a little bit too. All right, so what is a planner agent? I guess first I really should have had a slide that what is an agent, but at this point, I'm guessing that most people here kind of know what an agent is. Usually, I mean, I guess it doesn't have to be an LLM, but right now, usually it's an LLM that has access to some sort of tool, and it can call that thing when it needs to do a task that it's appropriate for. So even now, most of the time, like ChatGPT or these chat bots that you're communicating with usually call tools for like searching or generating images. And technically, you could think of that as an agent. What is a planner agent, though? And there's different types of design patterns that you'll keep seeing. You've probably heard of or you may have heard of React agents and reflection agents and planner agents. And I can cover those in different workshops. And in fact, if you look at the code and open that up, you might see there's already some examples in there. But the planner agent design pattern basically takes in a task, which is like a goal interpretation. So you would ask it something. This is like this node here. And then it decomposes that task. So if I said, we'll see an example of this of like having multiple agents. But if I'm going to say like search for a country's GDP and then calculate 5% of it, that would need to do a search. So we call it like a search tool or a search agent, get those results. And then maybe there's a math tool or a math agent that takes that GDP as context in and then calculates the percentage of it. And in that case, it had like one step and then another step that it had to do after the first step. But with a planner agent, a really cool thing is that you can add tasks or run tasks in parallel. So if you said like a more complex task, like, search for 5 different countries at once, get all their GDP, and then calculate 5% of it. It could run all those 5 searches in parallel, and that would be much faster than doing one after the other, and then do that calculation right after. So planner agents are really cool about allowing that, like kind of upfront parallelism and speed. Does the tool and agent routing. It should be able to do some sort of context handling. So just one thing to think about when you're doing like multi-agent systems is how do you pass context, in this case, like a result from one of the previous agents, like that search agent, into the next agent, like the calculation example. And then it should do dependency mapping. Just like I said, it should figure out like it could run these 3 at once and then run the next one because it's waiting on results from these 3 or one of those tasks. It generates a plan which is kind of nice. So you can actually, I have it as a pro down here. You can kind of audit or validate that plan. And so it generates a plan. This usually looks like JSON. And then there's some sort of executor that goes and executes that plan in different ways. So some of the pros for planner agents is, like I mentioned, speed. It's really easy to do parallelism upfront. It's auditable as well. So you could have some sort of validation plan, and it's easy to interpret. You can see the plan it came up with and then how it ran it. But some cons is it's less adaptive. And then also, if the plan wasn't correct and it like did something very upfront in its plan, it's kind of fragile. So it could kind of break the rest of the plan. So you, again, talking about React agents, which is probably the other more popular one that you may have heard as well. That does a action. So it might go search for that thing, and then it would search for the next one, and then it would reflect on the search results and then say, cool, my task isn't done yet. I'm going to go for the next search, reflect on it. My task isn't done yet, and then do the calculations. So great thing about that is it's adaptive, and you can kind of figure out if it did a right step or not and then correct it. But it can't plan out these like parallel waves, at least by default, the way that it works. So a common thing that you do is actually combine them. So you can have like a planner and React agent, and the React agent could come up with a smaller plan, maybe do all those steps, reflect on the outputs, and then come up with another layer of plan. So you can kind of combine these different design patterns. But today we're just going to be building the planner agent. If you want, again, I have in the code examples a React example. Also, I want to know, what would you want to see next as another workshop? Would you want to see a different type of agent pattern like React, reflection? There's other ones as well. Let me know in the chat what you would like to see next, because we will do more of these. It doesn't have to be about agents as well. I'm going to do some stuff on like fine tuning and reinforcement learning on LMs. Also some stuff probably outside of LMs, but LMs are a lot of fun. So let me know in the chat what you want to see next. Maybe you're even building something and you want to see how to implement it. Let me know. But I'm thinking about doing React agents, reflection agents. What sounds the most interesting to everyone? Someone said RL on reinforcement learning on LMs sounds interesting. Awesome. Great. Well, that's in my pipeline that I'm working on. So keep an eye out for that. And then why multi-agents? So if you haven't built a lot of agent stuff before, the way like that we're going to build it today, there's different ways to do this, right? It depends on your applications. The way that we're going to build it today is we're going to have one planner agent that is kind of coming up with a plan of how to do everything. And then all these steps, like when it calls for search and when it calls for getting the weather and it calls for doing math or anything like that, and I'll show you how to implement your own agents as well. So I'll give you like a template today, and then you can go come up with different tools and different agents, whatever you want to do. But what it's going to do today is, instead of just calling a tool as a step, it's going to call an agent as a step. And so we're building a multi-agent system. So instead of just a search tool, this planner agent is going to call a search agent, and it's going to call a math agent. And there's different reasons why you might want to break it down this way. Again, it's up to you how you want to do it for your application. But I think most of the time it makes sense to kind of do a multi-agent pattern. You get task decomposability. So those complex tasks, you can break it down to smaller things like 2 separate agents, like searching. You can also, I think I have this mentioned down here, but you have like independent, I guess, yeah, agent independency. So like each agent's kind of independent. And even if your agent is just kind of another prompt, like you're saying, here's how to do search, or here's how to do math, and I'm going to pass you these tools for it. It's kind of nice to have that prompt separated, especially when they're getting really, really complex and you have really long prompts or context windows. Because if you fiddle with like the planner agent prompt, for example, and you had the search prompt in there as well, even though you're not really adjusting that, you like the search part of the prompt, you're adjusting the prompt overall, and so it can just lead to some more complexities of like how LLMs handle that, which you might have seen before. You have parallel execution, so an agent can search and parse those results while the other agents perform other tasks like calculations or other things in the background. So with the parallel execution, each one of these agent, we can just spin up as many agents as you want, do like the calculations or searches in parallel. So independent scaling is a huge thing. I already talked about the the agent independence, durability. So if another big thing that comes up is if you have like this planner agent, and in our case today, it's not doing like an insane amount of calculations or planning here, but imagine this like a more complex planner agent or combining with Reflect. And if you are doing a lot of time or spending a lot of time here coming up with a plan, you're also spending a lot of tokens potentially. And then you went to run your first agent. And this agent does an API tool call and it fails right at the step one, or maybe even later down in here. You don't want to have to restart from the beginning and spend all that time and tokens. So having durability kind of built in, where we'll actually see this in action with Flyte too, it's baked in. But if you have an agent fail or a tool call fail, you want to be able to kind of recover from like a last input output from either tool calls or multi-agents. So this kind of allows that to be easier as well. And then also a big thing is the tool call reliability. I forget what the kind of current research number is, but there's a certain point where if you've added kind of too many tools, like I forget what the number is, like it was 10 or 16, at a certain point, your LM gets a little less reliable calling those tools. So instead, you can have these agents, and then the math agent has all the math tools, and the research agent or search agent has all the search tools. And then so your planner can go to that agent, and then that agent can have a whole bunch of tools, but it doesn't have to rely on the reliability of calling all those tools in one single agent. So most of the time, I kind of like breaking stuff down into multi-agents right now, but also curious to hear what people's thoughts are on this. Like if you've been doing multi-agents or you've been having a lot of success with just like a single LM handling tool calls. So again, just a little tiny bit about Flyte, because the SDK we're going to use today. Again, up to you though. You could strip that part away if you didn't like it, and you'll learn about how to just build the planner agent as well. So Flyte's been widely adopted to build durable AI pipelines. I can pretty much guarantee that every single person here has already used a model. You might not have used Flyte yet, but let me know in the chat. Does anyone already know Flyte, Flyte? But I can almost guarantee every single one of you has used a model trained with Flyte, from LLMs or social media, listening to music, self-driving cars, a lot in the autonomous space. Flyte's kind of the widely adopted open source orchestration platform for training models. But we just released in beta right now, Flyte 2.0. So it brings in pure Python. The first one, you had to build a workflow DAG that would kind of get compiled, and there's a little bit of a domain-specific language to that, so it wasn't 100% pure Python, but it was very close. This one, there's no DSL. You can do if statements, loops, etc. in your workflow, which is really cool. You get fan out with async IO. This is in the platform here. This is where we're going to build today. So these are all individual agents fanning out. And then these are tool calls that they're doing. And all this is being tracked. And the input and output is all being tracked. And the versions are all being tracked. So you get built-in observability. You also get that built-in kind of durability that I talked about. Like if one of these fails, it has built-in retries. But there's a whole bunch of other durability aspects you can do, like automatically having your agent overwrite the infrastructure that it runs on too. So now you can do all those things like try-catch. It still runs in Kubernetes on cloud or on-prem. And then also you get the remote image builder. So every single one of our agents today, again, for production grade, this is great, is going to be a containerized thing. And it manages building that container. It's all in Python 2, so you don't have to mess with Docker files. So again, super scalable and reliable. So here's a kind of multi-agent example. Again, we're going to build something like this today. You can see agents are tasks. We'll talk about what tasks are here in a little bit and look at the code. So again, we're going to go through code here in a minute. Again, everything is versioned. The input output is all logged. The logs are logged, so you can debug really easily here as well. There's metrics, so you can see, did I over provision like the memory and CPU cost? And I can bring that down. You have embedded reports, so you can actually embed any HTML or Markdown, even more complex HTML reports, things from like Python libraries that generate interactive reports. You can embed directly in here. This is really cool if you're doing like a research agent. You can actually put the results in here. You can have separate tabs for like what it searched and found. All the task info is logged. So again, like what were the secrets used? What was the memory, the compute used? And then you can rerun very easily from the UI or from the remote SDK. So this is a core part, and this is going to be the code that we're using today. So I'm just breaking it down before we open up the code and run this. So environments of Flyte 2, we have a config.py in the code that we're going to be running. It has one of these. This is kind of the core part of defining our agent here. So instead of building a Docker file, like I mentioned, this is where your configurations live for that agent container. It's compute aware, has image spec. That's the builder. So we actually just define our image here with this requirements.txt, but you could pass in other things like apt-get to install specific versions of CUDA, etc. We pass in secrets. So here I pass an OpenAI key and Tavily, and then this will be read into the environment. And then this basically creates a container that can be isolated. So if you're using something like a code agent, you probably don't want to reuse the same container for it, because if it's doing executions that could be risky and it could destroy something in there, you might want that completely isolated. But if you want to reuse a container, so if we want to make our agents run faster today and we're not doing anything super risky, we can have this reusable container. Basically, this container is going to stay hot, and then we can reuse it in other tasks. So it's super, super fast. But we still get all that reproducibility and durability aspects of containers here. You can also host models. So here's the compute aware part. So we pass in a CPU and the memory that we want for our agent here. And then in this case, I had a GPU. For what we're running today, we'll just be using API calls, so we don't need a GPU. But you could host in like small language models directly in this container as well, spin it up, use that reusable container, and then you don't have to load in that model every time for a task. So this is a task, again, an agent in this case. Again, we'll look at the full code here shortly, but this is going to be how we define our agents. It's going to be an async Python function, so they can run in parallel, and Flyte will automatically look at when you do async gather and then fan those out for you. So here we just have our async Python function. On top of it, we've imported this environment variable, or we created this environment variable of the Flask environment. Then we just say on the decorator env.task, and then we can tie these together however we want. With this, so you can think of this as like a unit of execution. It's containerized. You can run other tasks in this task. So this is really a workflow. And in fact, this is an example of building a React workflow. It's strongly typed, so we do kind of require you to say what the input is and the output. You can also accept Pydantic models. You get the serialization. So in between tasks and containers, if you're passing it back and forth, we'll actually serialize and deserialize the data and information between those containers. It's observable. So again, you saw a little bit of a preview. We'll see this here again in a second. Everything's logged. So all the versions, if you want to go back and look at the observability, what did your agent do? You can go do that directly in the platform. You can also pull those logs, anything down that you see like input outputs from the remote SDK. So once you do a run, you can pull the results down and look at them and even do some sort of the evaluation on them. Again, it uses async IO. And oh, I didn't mention this before. We'll see this in action. You can also run local or remote really easily. So you just kind of overwrite the config and say, this is running in production or my cloud test environment. Otherwise, I can use like a local flag, and then it just runs locally on my PC, and it allows for a really, really quick iteration. Basically, you write the logic, whatever you want. You can also use different agent frameworks. We're not using one today, but if you're using LangGraph or CrewAI, we make that really easy as well. Basically, you write the logic, and then Flyte orchestrates it on the compute and handles all the containerization. And then just one other quick thing to note, again, we'll see this in action, is traces. So we have the task, that's a containerized thing. If you're calling functions, like tools in this case, for your agent, we can just add a trace to it. And then this gives you the observability piece where it's going to log the input and output, but it's running in the parent container like this research agent. It's just calling this tool in there. You also get some of the recovery aspects like retries and stuff built in when you're using traces as well, which is super convenient. So again, if this web search failed from API limits or just something being down, which is going to happen at some point, it'll be able to do retries and hopefully recover gracefully from it. And like I mentioned, so you get the retries out of the box. I think the retries is 3, but you can overwrite it inside your task environment or traces to do more, and it will show up in the UI. It's kind of hard to see maybe in your screen, but you get a certain attempt here. So again, you can go back and debug, and you get all the observability of failures, and then you can see that it ends up succeeding after the 3rd try here. And then one other quick note is that you can adjust your infrastructure based on errors. So in this case, like our agent ran out of memory, we can actually overwrite the config. So you saw when we gave the amount of memory of 2 gigabytes, here I had 250, and then it had an out of memory error. You can dynamically overwrite the infrastructure, again, directly in the code, which is really cool. So you just see that out of memory error, and then you can up the memory. And you can have like a list to cycle through. So your agent isn't just going crazy, but you can give it the power of overwriting its own infrastructure, which is exciting. All right, so super fast, quick intro. Who's ready to run some code? Again, I'm going to paste this in the chat here. Oh, and I'll quickly note too. So as hopefully you're opening that up, I've given people, again, if you signed up for the Luma account and you're going to follow along, I gave your email that you signed up with access to our demo cluster, which we'll see here. But if you do want to actually get access to like run in your project or something like that, like you like what you see here today, fill out the form on union.ai/beta. And that's available today in Union. You can try it out. We have customers already building agents and other workflows on it. And the open source is currently SDK. Let me get that link because I didn't actually link it here. So you can check out the SDK here. And then full general availability of this being open source. So like Flyte v1 has been open source for quite some time. And like I mentioned, it's widely adopted by thousands of companies. So Flyte v2 2.0 is coming soon. General availability, I think target is the probably closer to the end of Q1. So very soon. So if you like what you see today again, the open source is coming out soon. So hopefully you'll want to check that out. All right, so I'm going to go to the code. Actually, I'll pause if anyone has any questions so far. And then I'm going to go ahead and open the code, walk through it, answer questions that people have. And I'll show you how to do it in CodeSpaces if you don't want to set up an environment locally right now. It only actually takes like a minute. It's really easy in CodeSpaces. And like I'd mentioned, if you already have UV installed and you're comfortable with your terminal and you have Git, it should also just take a minute to set this up locally if you want as well. Any questions? Any thoughts? I see quite a few people on the stream, but people aren't talking in the chat. It's hard when you're doing it virtual to read the room. All right, so like I'd mentioned, there's multiple tutorials in here as well, but we're going to do this planner multi-agent system one today. And there's a couple ways that we can launch this. So I'm just going to go ahead and click on this code button. But if you do go to the repo, you'll also see this button up top, this open in GitHub CodeSpaces. Yeah, that should work as well. But from this repo, if you just want to run anything in here, you can hit this code button and you can hit create code space on main. And then you get a whole instance of VS Code. I'm going to exit out of this Copilot chat window, and it's going to pull in the repo that we were just in. And the tutorials are all nested in this tutorial folder. So if you click in, let me get a minute to load stuff in, click in, and then you'll see this folder here. That's the multi-agent workflow folder. And I'm going to click in there. And then there's a README in there, and that has, well, there's different ways we could do this. I think I've set up instructions in here too. But directly in this multi-agent workflow, let's actually open up this planner agent.notebook. Like I'd mentioned, I usually run this in Colab, but there's that Colab issue. So I had to kind of pivot and figure out how to do this in CodeSpaces. So hopefully this goes smooth. Someone said, is Colab okay too? If you run in Colab, like I said, I think there's a bug that they introduced last week. So I actually wouldn't do Colab yet for this example, for any of these structured Python examples until either they fix it or I figure out a good workaround. So I'd recommend CodeSpaces or locally for today. I apologize for that. Hopefully we'll have Colab going again next time. Or you can just read the code. Also with Colab, it's harder to change or add .py files. You can do it. But with VS Code, CodeSpaces, or locally, you can hopefully then add your own agent much easier than if you did this in Colab as well. Cool, and I see a thumbs up. Awesome. So here, if you are doing this in CodeSpaces, all you need to do is basically copy all these things down here, and it will take just a minute to install everything. So actually, in the README, I guess I just double-clicked in, and then I copy this little setup instructions. Then I'm going to paste it into my terminal here, and it says allow paste. I'm going to click allow, and then I'm going to hit enter. And then this should basically be good to go for setting up in the CodeSpaces. If you're running it locally, you probably don't need this keyrings alt, so don't copy that. That specifically, CodeSpaces doesn't have a keyring. If you don't have a keyring installed, when you authenticate into the Union platform and then run something, it's going to ask you every time to authenticate. So this keyring alt gives a place to kind of temporarily save that password or authentication. And then if you already have UV installed, you can just skip this first step. So if you are running this locally, basically you can just copy this middle part if you already have UV installed, and then you should be good to go as well. You can run this first element if you want, but actually, well, if you want to run the notebook in here, you can hit run, and then that installs a Jupyter extension. I'll go ahead and do that, but you can also just run the commands in this notebook directly in your terminal now. You don't have to run them in the code cells here. I'm going to go ahead and do it though, just in case if people want to. Ran that first thing, installing the Jupyter extension, and then you just have to select the environment that we just created from that last step as your Python environment. So we should already have this one that we just created, this Python 3.11. And then if I want to, now I can run stuff in here. But most of this notebook is actually just looking at other files kind of in a structured format here. So you can go ahead and click around on these files now and edit them and have full access to whatever you want, add new files, etc. But the notebook's kind of a structured way to look at the project here. So in our requirements, we're just installing OpenAI, .env. I like using the .env to read in local environment variables, and then Flyte, and then Beautiful Soup because we're doing some stuff with scraping here. And then Tavily we're actually not using for this tutorial, but Tavily, if you want to do better search agents, I show an example of a DuckDuckGo one here, which you don't need a separate API. So it's kind of easy for this workshop. Tavily is a really cool API though. If you want to add search to your agents or LLMs, I definitely recommend checking them out. I'll use them in future tutorials for sure. And then in our config.py, so again, if I actually navigate over, again, all in this multi-agent workflow example here, if I go look at this config file, it's going to look the same as what you see here. So I could open this up if I want. And then we can see this is that config that I kind of showed in the slides. This is our base task environment for all of our agents. But I'll show you in each agent, there's like a commented out section for overwriting this. So I'm going to start with the base one. For today, I'm okay if they all share the environment. But like I said, sometimes you're going to want different resources, different API keys. Maybe you don't want them running in the same container, like for code execution. So you can overwrite this really easily within each agent module and then give it its completely isolated environment if you want. But for today, we're just creating an environment. We're going to call it base environment. It's going to inherit from this Debian base image. And then we're going to pip install that requirements file that we just looked at into it. And then we're going to pass in an API key. And this API key should already be set for you. So this actually, it is in the notebook a little bit later, but you can set secrets. So Flyte and Union can manage your remote secrets as well. And this one remotely is called Sage OpenAI key. And then we read it into the environment as this OpenAI key here. And then we're giving it just 2 CPUs. We actually probably should just do 1 and 1 gigabyte of memory here. We can look at the metrics and see we over provisioned it, but we're just calling it API. So it should be pretty simple in this case. And then we have this reuse policy. So it's going to keep this container hot. It's going to spin up a maximum of 2 replicas for us. And then it's going to have a time to life of 60 seconds before it scales down. So if we don't call another thing within those 60 seconds, then it's going to scale down. And then it's going to be able to run 5 things at once concurrently in it. So you can adjust these numbers as well. One thing to note too, the cluster that we're on today, which is this like try v2 demo external cluster, there's not a massive amount of compute in it, I don't think. So if we're all running stuff at the same time, things might seem slow. It's probably because stuff is just in the queue. If that is the case, I can go to another demo cluster and show how fast it is without that. Just noting that as well. All right, so then we have our config. Then I have a couple utility functions that I want to talk about briefly. This is not a Union or Flyte thing, but because we're not using an agent framework, what I did is I just made 2 decorators. It's almost no code, especially without the doc string. The doc strings are way more code or way more lines than the actual code here. We have 2 decorators. One is an agent registry, and then the other is basically a tool registry. And this allows us to basically, when we create an agent, which we'll see here shortly, we just add an agent decorator on top. And then it's going to add those all to a list. And then same with tools. But with tools, we can assign those tools to a specific agent. So instead of hard coding lists or anything like that, because we're not using a framework, just these 2 decorators is going to give us a lot of kind of agent syntax. And then allow us to really easily just port over those whole agent lists and tool lists into other sub-agents. So we don't have to hard code them into the prompts or anything like that. Then we have this logger, not really interesting. This is for logging locally. So if you're running your agent locally here, you'll get some output logs. And then we have this plan executor, and this will go into more details here, but this is actually going to execute a plan from a specialized agent like the math agent or weather agent, not from the actual planner agent. That's a separate workflow for it. So if I go back to the tutorial notebook real quick, I think there's a couple other just setup things. You don't have to run this, but I want to mention it. So you should already have this .flyte file here. Normally this is a file in my git ignore, but I added up with a config for you because I knew you're all going to be running on the same thing for the workshop today. We can see that if we ran this, we're saying we want to run our workflows remotely at this endpoint. The auth type in this case is headless. So it's going to open up a new window with a code on it, and this will work in things like Colab Notebook if it rendered the link correctly, and things like the GitHub code spaces. If you're running this locally, you can get rid of this line because you can open up a browser. And then we are setting our builder to remote. So when that container image that we had defined in that config.py, if it doesn't exist, when we try to run our agent, Union's going to look. And then if it doesn't exist, it's going to build it. If it does exist, then it's going to skip the build and just run on that image. And then you have domains, defaults. It's like development, production, prod. Development and production. And so you can have different areas of where to run this. So you might have different API keys or something for each one, secrets, etc. And then in this case, our project here is called Planner Workshops. And this is where all of our runs are going to live today. If you run this, again, you don't have to run it because you already have it. But if you run it, it creates a file that looks like this. And you can create multiple ones of these files. So when we do the CLI entry point to run your agent, you can have like an input flag, and you could have multiple config files, one for development, one for production, different projects. And you could actually have it read from different config files if you want. And if you have your own Union endpoint, like you're already a Union customer, you could just adjust your endpoint here. Right, and let's see. Oh yeah, for setting up. So if you want to run this locally as well, you're gonna have to get your own API key. And I thought I already had my window up. I guess I don't. I might grab an API key here in a second. If you want, you could just run this code cell, and I'll have a little input, and you could input your OpenAI API key. Actually, let me go ahead and get one real quick. I have one. Sorry, give me 1 second here. This is one part where I forgot to be prepared. All right, actually, I think I have a local one. Nobody look. I'm going to just grab my here. I'll delete this later. So this is my whole workshop thing locally as well. And so I will just run this just to make sure it works here. Wants me to input the OpenAI API key. And then now it should be set. But what I like to do if you're actually developing this locally, and so if you're going to extend this project further, is I would recommend creating just within this folder a .env. Is the way I like to store my API keys. I know you can also just do it as a path. And then you would just have like open API key, and then you just say equal, and then paste it here, save it, and you can add like your Taverly keys and anything like that as well. So that's the way I would really recommend doing it if you're setting this up locally. But if you're just following for the workshop and want to run the notebook, you can just input it there. And then if you want to set the Flyte secrets, which I actually don't think you have access on this cluster to even do this, I already set one for you. So when you run the remote cluster, you'll access my API key I put in there. Again, I'll delete that later too, so don't abuse it. But you would create your own secret by saying Flyte create secret, give it a name, and then this will be created scoped in that project that you have access to. And then you can call it in that config.py that we saw, not the config YAML, in the config.py. So this is what it's going to be looking for. This is the name that you give it there, and then you can read into that environment with this. So one will already be set. And then if you are following along and you actually ran those commands, fingers crossed, pray to the demo gods that we should be ready to actually run this. And this is going to just be a first very simple agent run. And again, we'll walk through the agent code here, but this is just to confirm that your setup is right. And so for me, I'm running this in the code cell. You can see I get this authenticate link. I can click on this, and then my email's already here, so I'm gonna sign in. Then I should be authenticated. If it's your first time, like I'd mentioned, I gave access to this cluster for the emails that signed up, and you might have to enter like a little bit more info if it's your first time doing this and getting that remote link. So let me know actually in the chat what the current process is for that, because I was already signed up and I didn't go through the new onboarding flow. So once I'm signed in, and because I had actually already run this before and my image is already built, otherwise, if it's your first time running this and you weren't in the same project as me, you wouldn't have access to that image. So it's a image doesn't exist and it's going to build that image, which might take a minute. And then we get this link here where I can click on this, and then this gives me the area where it's running the workflow. Because I don't think we ran one here in a little bit, this might take a minute to spin up for the first time. And then it should be much faster to run. Also, if a lot of people are following along, it could be hogging up some of the compute here. But there we go. It again usually spins up much faster than that. And then now we're running, and we have this super simple planner agent where we just asked it one thing. We can see that it created a plan here. And then we can see that it called this math agent. Again, this is a separate task. And here's the outputs and inputs. And then the math agent also called this add tool. And we can see that the inputs here was 2 and 2. And then it gave us 4. So it looks like the tool was working. So if you were able to run that, again, let me know in the chat. And then we'll be off to the races for basically running everything else that you want. If you want to run a more complex thing here, since we already did that, you have this local flag. And if you set your API key locally, now this should run. So this is a much more complex task here. We're asked to think a lot of how to do things in parallel and come up with an actual plan. So I'm going to go ahead and stop this locally, but we can see that it's working because I set my API key both in the env, but I did it the other way in the notebook as well. And now let's run that much more complex task here and see how this looks in the platform. We see instantly running right now, already doing our planner agent. And then this is much more complex, so it's going to take a few seconds, come up with a plan. And we see in parallel, we have all these agents going now. We can see all those tool calls happening at once. Someone sent an emoji in there that I can't tell if it's like a hand raising. To me, at least the way I see it in StreamYard, looks like a hand raised dinosaur with headphones. So I'm not sure if you're raising your hand or excited. If you have a question, though, feel free to ask. Oh, it's somebody I know with a different account that I've never seen before. Again, things also look different in StreamYard a little bit. All right, so we had all this run, and this is really cool, and hopefully you can kind of see some of the power of what we're doing here, and we'll go through all the agent stuff here now that we're set up. So call it all these different agents. It's calling all these different tools. Again, all those inputs, outputs are logged, and then we get a final result returned here as well, which in our case is showing like all the results together, combining these, and then we can pull these down, which I show in the later code cells. After you've run this, you can use a remote SDK, pull all this information down, do whatever you want with it. But now that we're all set up, we've gone through everything in terms of like concepts too. Let me go through more of the actual agent piece. So in this code walkthrough, I already talked about the decorators. I already talked about the planner a little bit. So this is the plan executor that when the math agent or weather agent says to do something, basically in the response, it says like what it wants to do, like what tools to call. And then you parse those response. And then we have this little JSON parser that does that. And then we have this executor. So we'll look at that, what was parsed, and then we'll call the different tools with the values that it passed through. And this is what happens under the hood of most frameworks. So if you're using something like LangGraph and you're using the tool type of thing, it's handling this for you. In this case, we're kind of implementing this all in Python. One thing with frameworks too that I've seen a lot of is they're great to get started. Really cool. I like them. Sometimes if you're doing stuff in production, you want more control exactly how things are handled, like the actual React loop and stuff like that. And then you start breaking away from these pre-built conventions inside the frameworks. And then I see people move off of them. So at least that's been the case the last couple of years, and those frameworks are maturing more. So I'm not saying don't use them. I'm just saying that you can go implement basically all those things that happen under the hood. And it looks like a lot of code because it's a lot more than the framework, but it's actually really usually not that much code. And then you get full control over all those different steps. So let's look at the tools. And I'm actually just going to go ahead and open up this tool folder. So right now you can see there's code tools, math tools, string tools, weather tools, web search tools. You can go implement your own after this or during this. It's actually really easy to do. So inside this math tool, we have multiple functions. So what a tool basically is just a async Python function here. And we're giving it 2 inputs because it's just adding. And we type them. And our type here, we wanted to be able to handle, in this case, int, float, and string, but you could have like just an int or a string or whatever you're doing here. I came up with a little combined type here that I could pass all those in. And then I'm returning a float. And then I give it a doc string. And this is a convention in most frameworks as well. And this actually, we'll see how this is handled in our agent. But I also use this convention where you give it a doc string, and then the agent who has access to that tool will get a list of tools and then read in those doc strings. So it gets a description of how to use it. So this is really helpful, not just for you as a human reading it, but actually telling your agent how to use this tool as well. So I recommend putting a good doc string on your tool. Again, a pretty widely used convention right now for defining tools for LMs. And then here, we're just converting to floats. So if it was a different input, convert it to a float. And then we're just going to add those and return it. Oh, and I left a print statement. I should remove this. I should at least make it a log, not a print, probably here. But you could also just remove this. And that's a tool call. And then we have this tool decorator on top, and we're assigning it to the math agent. So like I was saying, in this case, for the architecture today, we're breaking it down where we have these specialized agents, and then they can have as many tools as they want. And so this tool decorator that we define in that decorator stop high makes it really easy to assign to specific agents. So again, gives us some kind of framework syntax with just very little few amount of code. And then we have this Flyte trace, which is what allows us to, in the platform, get this piece where we have the observability that it was called. We have the observability of the input and output. And like I mentioned, there's some of the recovering pieces too. So if this actually did fail, the retries are built into that as well. And then, so we do this multiple times for different math functions. And I only have like 3 in here. You can imagine expanding this to a lot. And part of the math function, like it seems really easy and very simple. But if you might recall, LMs were really bad at doing math a long time ago. And I think still sometimes. So especially depending on the model. And I should mention, well, we'll see it on the agent part, but today is also pretty model agnostic. So we're using OpenAI API, but you can switch it out with any other API. You could also bring in a small language model. So if your small language model is not great at doing math, but really good at doing tool calling, then you would build out like these math tools, and then you might rely on it for that. So let's look at weather tools real quick, and then we'll look at the agent part. So the weather tool, very same concept. It's a async function. We have flight.trace, and then we have this tool decorator, but we're assigning it to the weather agent. We'll look at these agents here right after this. We're getting a location, returning a dictionary, again, a doc string describing what it does to tell the LM and you. And then we're just doing a call to this API, and it's going to get some information back. In this case, it's going to get location, temperature, condition, etc. And then this will all be returned as a JSON string. So pretty simple here. So now let's go look at the agents. So I'm going to collapse the tool folder, look at this agent folder, and let's look at the math agent first. And again, this seems like a lot, but it's mostly just prompts. We have a little bit of config here. This is just because we're using the OpenAI API. So again, you could have different config, or you could put this somewhere else. We're going to use the 4.0 mini, temperature 0, because we want to do math. We don't need to make up how to do math in this case. The temperature, if you don't remember, is basically saying how creative to be in some ways for your LM. And you can give it a max token. So if you're doing longer responses, you can add in a longer max token. Just remember that you're paying for this token. So another nice thing is for these specialized agents is you can use lighter weight models and not have to rely on like a more expensive model that is doing the planning piece. You can have a really small, cheap model in these sub agents that does a really good job of the thing you're trying to do. And you could have smaller amount of tokens and stuff. So you have a lot more control when you break out the agents into multi agents. We have a data class here. This is what our agent's going to return. So it's just returning a final result and then the steps and if there was any errors. And this, we're inheriting that base environment that we created in that config.py. But like I'd mentioned, you could uncomment this and then you'd have your own environment. So if you want to install different packages here, if you want to have it isolated, if you want different secrets, you don't want those scoped to the other agents, you can do all that really easily in a few lines of code. Then here we're actually defining our agent. So again, we have this agent decorator. We give it a name, math. And now when we assign those tools to the math agent, it's going to be able to read those in, which we'll see down here. And then we have the task environment. So again, we inherited that task environment. So this is a container now, and it's going to run inside that container with access to those API keys and compute resources and Docker container that we defined in our code. We have a little doc string. We're not, actually, I think we do read this in for the planner agent. So again, you might want to have a good doc string here, kind of saying what it does or like what its expertise is in. And then we're initializing the OpenAI client. And then here we're reading that tool set. So we're reading that agent tool list that's made from the decorator, but we're just getting the ones that were assigned to math. And then we're reading in the doc string here. So now as part of our prompt, we say you are a math agent that can solve arithmetic powers and multi-step problems. And then this tool list now becomes that list of tools that we had created with the decorator and those doc strings. So it can have a lot of, not observability, a lot of details of how to run those tools. And then we add critical, you must respond only in valid JSON. Quick note on this, because I wanted this tutorial to be pretty model and API agnostic, I'm kind of really telling it to reply only in JSON. It does a good job with the current models that I have set up. If you're putting this in production, one, a lot of the APIs now have structured responses. So actually, if you're using the OpenAI one in production, you can have structured responses and tell it to return in JSON, and it's going to be even more reliable than saying critical inside the prompt. There's also other tools like BAML and Instructor where you can use those to help you get structured output as well. But just for the tutorial today, want to have it model agnostic, not rely on another tool. So we're telling it to only respond to JSON. And it does work pretty good, but just noting in production, if you want the most reliability, I would look at one of those other features. And then we give it a example of what that looks like. So this is going to be the JSON that this math is responding, and that plan executor and that utility is going to use to execute the plan. And then we give it some rules. Again, you can adjust this prompt, as you probably already know, to make your agent behave differently. And then we're just going to wait the OpenAI here, the OpenAI LM, and then we're going to get that plan that it generated. And then we're going to use that parse plan from response. This was in the utils plan executor.py. So there's this little parse plan where it's just going to parse the JSON, because sometimes even though you say critical only return in JSON, it might say like, here it is, and then wrap it. So basically we just have a little lightweight parser. Again, in production, you might want to use another tool for this. And then we have the plan executor. So it's going to take in that JSON, that filtered JSON response, and then actually execute and run those tools like we had looked at. So again, weather agent is very similar, except for a different prompt, right? We're reading in different tools now. We say you get the tools inside weather. And the cool thing about these decorators is if I just make another tool and I add that decorator to it, the next time I run it, it's going to be able to pull all these in. So you're not, again, like hard coding or hard coding different tools to bring in here every time. Because if you didn't use decorators, you would have to put in this prompt manually, like here's your tool, here's the use case, etc. So these decorators just give you, again, a little bit of that agent syntax without using an agent framework. So I found it really helpful and really nice. I can create new agents, create new tools, and I don't have to remember to update my code somewhere else. So same thing, it just gets the different response back. So now if we look at the next step would actually be this planner agent piece. So this is the agent that's actually coming up with the plan. And then we have one other code file that's the planner workflow, and then we can test some stuff around more. Oh, I also, looking at my screen, I don't know, was it zoomed in enough for people? No one complained. Usually people will say, zoom in. Hopefully this is better. Hopefully it was okay before, but this might be better. In this planner agent, so it's another agent. We add the task decorator and we give it the agent planner decorator. And then here we're again initializing OpenAI API. And then instead of reading tools, though, the planner agent gets the agent registry. So again, if we just create new agents and add the other decorator, it'll read them all in, except for it skips planner because we don't want it to call on itself here. And then it reads in, I guess it might not read in the doc string here. I might add that as a feature later. No, it does, I think. But it'll read in the details of those agents and then understand how to call them. And then here's the prompt. Say you're a routing agent, available agents. And then it gets that whole list. It says analyze the user's request and decide which agents to use. And then dependencies. And it talks about how to handle the dependency. So you want it to specify like which steps have to run first, and then which wave can run second, which wave can run third. So it understands how to map everything out appropriately. And then again, it's telling like how to put in a list format so that when we get this plan generated, our actual execution workflow can know how to run all these and like run the dependencies when they need to be run. So again, just few shot learning here of how to give us some outputs. And then another important always include dependencies field for each step, even if it's empty. I think I had added that because it wasn't doing that at some point. And then we're basically initializing the API and then converting the steps and output to the data class above. And then this gets read into our last piece of the puzzle really here. Again, you can organize these however you want. I have this folder called workflows. And what these really are different design patterns. So if you want to poke around at these other ones, you can. So like I'd mentioned React before, you might be familiar with reflection and some of these other different ways of building agents. Basically, these are all different design patterns of how to call these multi-agents that we had already defined. So they're all multi-agent workflows. They use all those same agents, but it's different ways how to think and plan and execute things. So if we open this planner.py, this is calling it a workflow, design pattern, whatever you want to call it. We scroll down here. We are now defining our build task with context. An important thing to note is that originally, like when I built this planner agent and some of the other agents here, if you're doing these multi-agent steps, for example, if we said, what is it, going back to that GDP calculation example, if we said, what's the GDP of Japan? And it gave the result, and then it just runs the next agent, which is like the math agent, like calculate 5% of it. If it doesn't have the context from the previous one, then it's not really useful if you're asking about previous steps. Like you could say, do math, do this, but you can't combine them. So you have to know how to pass the context in. So what we do is just, we take a list of previous steps and the results, and then that gets passed in. And there's different ways of handling context. You've probably heard that. It's a really big thing right now. I feel like every database company is rebranding to say they're a context company. But basically, it's just different ways of how to pass information between these agents. And sometimes you'll get really, really long context and you need to summarize it down. Like if you use Claude Code, you've probably seen this before, it has a lot of context and has to compress it. So you could build like a summarizer type thing, only keep the most important things, only keep the output that says like, maybe this is our output and that's pretty small context. We don't need all the input for it either. So there's different ways of handling this. And we're just handling it this way by keeping output and then having that as a list that our next step can reference if needed. And that's what this little context piece is doing. And then we have our data models. Again, these are just defined outputs. And then again, our base model, we're inheriting from that base one, but you could overwrite it. And then we have our planner agent workflow here. So again, a little doc string about what it is. And then here, I have this broken down in comments. I put a lot of comments like giving this to you as a workshop. I felt like it was good to have it broken down into little sections like this. So some of this seems like a lot of comments, but I think it's good if you're just coming into it new and it's a little broken out. Someone said big results / final project. Not sure what is but it's a question, so I'm not sure what the question is. The big results, like I was saying, it's just you have to think about how to handle context if you're expecting to have big context come in. You might want to compress it with like a summarizer agent is a popular way to do that. But you have to think about, like, if you're summarizing, like, what details do you want to keep in? Here, we're just logging what's going on. You'll see a lot of logging. This makes it easy when we run this locally if you want to debug it and you can see all those traces. Actually, because I had done this before, I could open up this trace and this gives me like, oh, the reasoning, the what tool did it call, the timestamp, etc. That's kind of just what all the logging does. Oops. Exit it out of the thing, of course. I'm gonna double click on it and now it should stay up. Basically, while there's pending steps, it's going to go through, run each of those steps, look at dependencies for those steps, run the dependencies first if it needs to. Has the parallel step execution. So it's going to, where's the actual execution piece of this? Again, a lot of logging here. I'm just going to read in those dependencies and then basically just run these as async. And all this is doing is like seeing, like, there's some error handling too. So if that agent isn't in the function, then say unknown agent was called. Otherwise, we're going to wait that agent function and run all those dependency tasks in there. And then this is logging again. And then this is going to execute all the ready steps concurrently with this async io.gather. And again, if you run this locally, it should run async. But also when you do this in Flyte, like we saw before inside of the platform, it actually knows how to run all these different agents in parallel. You don't really have to do anything except for just run it as async, and it handled out basically the giant fan out of your infrastructure. So you can imagine, like, when people say, 1,000 agents is going to do something, or you want to manage this whole swarm, Union or Flyte 2 makes this really, really easy. And then we're going to store the completed results in this execution. And again, we can read those steps in from one of the other later ones. And then if you scroll down, here we have this kind of CLI entry point helper. So I just use arg parse, and I'm passing in different flags like local if I want to run this locally. If I don't have this flag, then it's going to run on the remote Flyte cluster. And then I have this request. This is a thing we're asking, like the calculate, do all the stuff, get the weather, etc. And then get output. I'll show this here in a second, but we can run get output, and then I'll actually pull in the latest from our run, or we can pass in a hash string to a specific run, and we'll get the output for that. So that's part of the Union Remote SDK, where basically anything you see in the platform, like here, all these inputs, outputs, logs and stuff like that, you can use the Union Remote SDK and then do this, like pull all this information down locally or into somewhere else. So if you like what you see in the UI, imagine being able to programmatically do that as well. And then there's just some if statements for those flags that I put in. So basically, if it's local, it'll overwrite the init with a different init. Otherwise, it's going to run from that config file that we saw near the beginning of our setup. And then if it does the fetch, this is the Union SDK part. So it's going to, our Union Remote. So it's going to initialize Union Remote. And then we're going to get this list all. And then we're going to get the latest run. And then print out the name and the outputs from it. Otherwise, we can pass in the hash and get the specific output from that one. So we go back, and if I actually just go back to the notebook here, and I'm going to scroll all the way down, we walk through all the code in code files instead of running through this as kind of a tutorial here. So we can try running these workflows again. So I'm going to take another example. Let's actually, and maybe hopefully you're trying to, if you're following along, which something we should ask this. So you see some of the agents that we had in there was code agents. I didn't walk through all these. I'll do a separate thing that's longer on code agents. This is a kind of a simple one, but it can write a Python thing if the function doesn't exist and then get us a result, which is pretty cool. Let's do a weather one real quick. Let's just say, what is the weather? We can probably have a typo. It's fine. What is the weather in Seattle? So this is really simple. We probably don't really need a whole giant planner agent system for this, but let's see what happens. It's running remote. So now I'll get this URL. We can go look at this again. As it's running there, I'll just go look at the other part of the code. So what I want to show, and there's different examples. So this is like kind of that GDP and then calculate percentage, the just kind of two-step one that I was talking about for a lot of examples. But let's look at the output here. So we can use this flag now. Let's see, did our weather one run? Oh, it's going slow again. Again, there might be, it's probably in the queue waiting for compute right now. But actually, I think if get output is just going to pull the latest one that's done anyway. So I'm going to run this and see what happens. Oops. Oh, I think I combined them somehow. Oh, forgot the P. So you can imagine accessing or also running these from an app. It doesn't have to be from your CLI. So we're doing that for like kind of the example today. I'll probably add actually an example of running this from like an app, which I think would be interesting. So the way we're running from the CLI is in kind of an eager execution mode where it's looking at all the latest code down here and then running it with whatever input we passed in. But you can also just have a registered task that now lives on Union, and then have an app like Gradio or anything like that interact with it, and then kick off that task from the remote SDK, basically. Oh, it says the result was 0 for my last run. Oh, there we go. I think it was just not done yet. So this is the weather one, and now it pulled in that result, and we could do whatever we want with this. So again, you can imagine doing this remotely in some other app or something like that. And then if you want a specific output from a previous one, I'll show you how to get this hash here in the platform too. But here is looking at output from a specific previous run that I had done before. So you go in the platform here, you can see this hash up here. You can just copy that. But basically, again, everything is versioned. So in terms of agents, this is like every agent run gets its own hash here, and you can go look at the entire lineage of what happened, the inputs, outputs between all those different tasks, which is awesome. But you could also imagine doing this for not just agents. So Union or Flyte isn't just an agent platform. Most people previously with V1 were using this for training large models. So you want to spin up a lot of compute and train like a large model. The input and output and lineage is completely or can be very critical there too. So when I see like what pre-processing happened to a data set, where did that data set come from? What were the hyperparameters? What was the code? All of that's stored in here, versioned, and you can roll back. For some industries, you also need that for auditability purposes. And you can also share this. So like you can rerun it from the UI. Your team can rerun something. Maybe they didn't want to write this workflow, but they wanted to trigger it or trigger it from the SDK. They can. You also have the code is all versioned in here too. So this was the last one that we just did with the get weather. But you can actually go see all the code that it used to run. Task level details, like who ran it, what API keys were used, what org was here, what was the compute assigned. Reports, I don't have an example in this agent, but this is what I showed towards the beginning, where you can actually embed HTML and really useful things in here, actually interactive stuff as well. Metrics, like I mentioned, let's see, do we over provision? Yeah, I don't even see the line for the cores that we used. Oh no, I think we actually might have in this case. But if we over provisioned how much memory we had here, that would show up here. Oh, maybe because this was super quick. Go look at these other runs. Oops. I saw it for a second. Oh, no data under 30 seconds. So I think these are just kind of too quick to accurately log the metrics there. All right, so I went through a whole bunch of stuff. I'll have to look and see if anyone actually followed along. If you didn't, I see quite a few people stayed through. So hopefully this was interesting to you and something that you want to go check out later. If you have questions, I would love to hear them now, but also later. And then I'm going to share just a couple useful links again. Check out Flyte, the docs. Oh, actually, I should probably get V2 docs. I don't think this goes to V2 yet by default. I'll pull these up. 1 second. Go check out the docs. Again, we were looking at V2 today, so link to those. If you want to join the Slack, ask questions there, maybe get a more personalized demo even or something for your use case, I'd love to hear about it. And then also check out all the events that we're doing. So we're doing a lot of stuff. Soon, we already have some really cool stuff up as well on Luma. Check out the AI Book Club that a lot of people find interesting. We're also hosting some events that I think are up there already down in San Jose and San Francisco in the next couple months. And I'll be at NVIDIA GDC, like I mentioned. So if anyone else is going to be at NVIDIA GDC and wants to meet up, let me know. And with that, one, I'd love to know what you think. Was this interesting? Did you like the Flyte part? Did you like just running an agent or seeing how to build and run an agent locally, even without the Flyte part? I'd love to know what you thought was kind of maybe some of the more interesting parts of today's kind of workshop, so I can use that for future workshops. I'll be sticking around. People are doing clapping emojis. Hopefully that's a good thing, I guess. Also, let me know after going through this, what you saw today, what type of agent type of thing would you like to see next, maybe? It could be a type of agent like React agent. It could be an agent framework. Maybe it's a specific type of project like a research agent. Looking to see kind of what people are building, what people are finding interesting, like what should I make more examples of? Code execution agents, probably pretty interesting, I think. Also using like the containerization part of Flyte is really cool with that. Seeing more clapping emojis. Also, I'll mention, so if you want to sign up and get access to the beta cluster outside of just today's workshop demo, go to union.ai/beta. And this is the Flyte 2 beta that we kind of saw today. The full open source is coming soon. V1 open source is already there. It's a little different than what we saw today. So if you really liked what you saw today, hold out for the V2 open source or join the beta on Union. Or sign up for Union and you can have access to this already in your Union cluster. Any other questions or comments before we wrap up the stream? Again, I think if someone wants to put in what type of agent workshops they'd like next, I'd love to hear it. Yeah, and we can see this is the project area. You can see all the different runs that I did here. Well, actually, I wonder. I have to see permissions. I only see me. Did anyone follow along remotely? No one said they ran into errors, which either means everything went super, super smooth, or no one actually followed along, which is fine too. Hopefully, you just found the content interesting enough to watch. But I am curious. Did anyone connect and run on the remote cluster? People are reacting a lot with emojis. Someone said they'll be running through afterwards. Awesome. And just a note on that. So I'll leave access up to this cluster for a bit. But at some point, I will probably tear it down. So you won't have infinite amount of time if you're coming back to this. But if you do want your own cluster later, like I was saying, or like I mentioned, join the beta. And that way too, I forget if I mentioned this at the beginning, because this is just like a temporary try V2 thing that you're in right now. If you're following along today, you're all in the same project here. So don't share anything sensitive in there. Don't put any secrets in that, even though you don't have permission to, I think, see all of them or write to them right now in the current project. Still, people could have access to it if they're running it remotely. So don't put anything sensitive in there. If you want your own thing, sign up for the beta. If you want your own project, at least that way secrets are scoped to your project and not shared across people. And for today, there's that OpenAI one in there. There's just my token right now, so I'll probably delete that later as well. And if you have questions, join me in the Slack, which I'll share that link one more time too before I wrap up the stream. There's also an intro channel in there. It's kind of fun when people do a more permanent intro into that community. And I still see quite a few people, so I'll hang out a little bit more. People aren't leaving for some reason, or more people are joining than leaving, which is possible too, I guess. You're coming at the end of the workshop, so you can watch the recording at this same link where you're watching the stream. Like I'd mentioned, the access to this specific project in that cluster will be turned off at some point, probably today or tomorrow. So if you do want to try and run through, I'll leave it up for a little bit. If you, like, right after this workshop, want to go try running it. But I'll stick around a little bit longer since, like I was saying, there's still quite a few people. But no one's giving me cool questions. Or no one's telling me what they want to see examples of next. All right, then I'm gonna wrap up the stream. If you have questions, join the Slack channel or message me on LinkedIn, and hopefully I can answer them. All right, I will hopefully talk to some of you all later, and excited to build more agents with each other.